So for today, we're going to be using a website called Replit. What Replit is it's an online compiler. A compiler is basically something that takes your code and makes it so it can run and actually do stuff on your computer. So if you want to go to repl.it or just replit.com, that should lead to their website, and you can just create an account with your school email or however you feel. But the reason why we're using this is just because it's easy. You don't have to download anything. It's actually probably the best online compiler that there is, just because it has some autofill options as well as other things that actually make it like not a pain in the butt to use. Normally, if you're using Unity or something, you may want to use Visual Studio if you're on Windows, or another application. Visual Studio Code is also a good option. And both of those are applications that you have to download that you could use if you want. But I'll give you a couple minutes to create an account. What's also nice about Replit though is that you can see other people's stuff that people have posted in variety of languages, but then you can see their project, you can run it, and you can also like see their code as well. So it's also just a nice learning tool to see a bunch of examples on stuff if you want to learn more. You should get to this page, I believe, once you sign up. It might have a little tutorial thing for you. Just click through that and then hit the create button in the top left. And this will let you create a new project. For a template, we're going to use C#, just because that is the language we're using today. C# is, they have a lot of languages on here. The reason why we picked C# for today is just because they use it with Unity. But it's also just a pretty good general purpose programming language. It's pretty similar to Java as well if you ever take computer science classes. But over on the right is a title, so I'm just going to name it GDC Workshop or something. You can name it whatever you want, and then hit Create REPL. Okay, let's see if I can. I'm going to make this nice and big. Okay, so let me space this out a bit. So once you create a new project, it kind of has like a template that's here. This is just some starting code that pretty much all C# programs will start with. I'm kind of going to try to explain a lot of this stuff to the best of my knowledge. If anybody has any questions, just like stop and ask me. So assuming that you're unfamiliar with what any of this is, we'll start top to bottom. Using system up here. So system is a library, and a library is basically just like a collection of code that somebody else has already written. In this case, Microsoft themselves is providing a bunch of stuff. And what using system says to the compiler is it's saying that, hey, we want to use this extra code other people have written, which provides a lot of this stuff down here. It'll make more sense as I talk about it later. Class program, I'll come back to actually. Just know that's there for now. And then there's this, the public static void main. So how every program starts is it has a function, which is like the entry point. It's where the code begins. In this case, it's called main. Same with Java, and I think most languages start with main. And then all the code that you write that will be executed is somewhere in between these curly brackets here. In this case, there's already some code written there, which I'll explain in a second. We'll come back to the other things as well. But if you were to hit play, this might help make some more sense. The big green button in the top. It'll take a second just because it's online. If you were on your own computer, this would take like a fraction of a second. But you'll see that it says hello world here at the bottom. And so this line here that is inside of the main curly brackets, this is saying to the console that we want to basically just print this out. So right line is is the function, or like the way that it tells to print to the console, which is like basically the output down here at the bottom. Let's just, we'll come back to a lot of this stuff just as time goes on, but let's start working with a couple of different things, typical code that you will use in most situations. So one thing that code is used for a lot is like math and stuff like that. So if you've ever done math, which I hope most of you have since you went through high school and stuff, we have things, there's a lot of things in variables, or sorry, there's a lot of things in math that will apply to coding like variables. So usually when you write a math problem, you'll have something like x equals y plus b or whatever in algebra. Well, in coding, we can also use variables to create a bunch of different things. And this is how you were to like store data. If you want to do some math calculations, you can set x equal to something and so on. How you do it in C# is it follows the format kind of something like this, where you have a type of the variable, and then the name of the variable equals, and then the value. And okay, so there's several different types. There's actually a lot of different types. They're commonly referred to as either classes or primitive types. And I have 4 written down that I want to talk about really quick that you'll probably use most of the time. There are different ones which have different situations that you might use them in. But the 4 main ones are int, float, char, and string. So an int is short for integer, and this is like any whole number. It's like 1 or 0 or like 52. A float is a floating point, and what this means is basically any type of decimal point, decimal number. So if you have like 1.5 or 3.14, or you can also store like whole numbers, so it could just be like 2.0 or something. A char, or it's short for character, is just like a letter, basically. And this can be like A, or maybe a space, or like a plus sign or something, just an individual letter or character of some sort. And then a string is like a phrase or like a word or something where it has a bunch of different characters, like the word hello would be a string. And so if we come back to the code now, I'm going to take this hello world and I'm going to put this inside of a variable, and hopefully this will make a little bit of sense. So if you look back at the types that we've got the int, float, char, string, and because we're using a word or a phrase in this case, it's going to be a string. And so if we want to make a way to store that, we could use a string like this such, and then we can name it whatever you want. Usually when you name things, you want to try to make it something that makes sense. So I'm just going to call it like hello equals, and then it would be something like this, right? But how we tell the compiler, how we tell the program that we know that it's like a phrase of characters, we put double quotes around it, and you'll see it changes colors as well, which helps signify that it's a string. Ignore that little squiggly line. So now we have this variable, hello. And I'm actually going to delete this out of here and replace it with the variable name, like so. And so basically what this is doing now is when it prints to the console down here, instead of it just doing hello world, it'll actually print whatever is inside of this variable. So if I hit run again, and give it a second, it'll still print hello world, just because that's what we have inside of this variable, since we set hello equals hello world. So if you want it to print something different, all you'd have to do is change what's inside of here, like that. And then if you hit run again, then it should display the new value that we have assigned it. So I also want to provide some different examples with the other types. Say that you want to do some math, for example. In this case, if we want to do math, you have two primary options, either an integer or a float. Integers are nice for anything that's whole numbers. In most situations, if you're doing like actual math, you'll probably use a float because you're going to have half numbers, and you know, if you're using pi 3.14, then that's not a whole number, so you'll want to use a float anyways. So that's just what I'm going to use for now. Or hold on, here, we'll do int to start. Actually, I lied. So we'll do int x equals 5. So this creates a variable which we have named x, and it's a whole number which is equal to the value of 5. And if we want to display this to the screen, all we have to do is switch out, we can delete hello, and then we put in the name of the number variable, which is x. So now we'll have console.writeLine x. And then we can now print that to the screen, to the console. Okay, ignore that. But now you'll see it displays 5. So if we want to do some math, the easiest way to do it is just create another type of variable. So let's say we want to add 1.5 to 5. We'll do a float. We'll call this y, set it equal to 1.5. And you'll see that it has a squiggly line under it. And if you hover over it, it kind of tells you what it is. Basically, it's saying that if we want to use a decimal value, you have to put an f after it, just so it knows that it's a decimal point. And it knows it's a float. There are different types in C# which would use different things kind of similar. But just for now, just know that if you do a float, you have to have an f after the number. And then if we want to display the result, we'll use another console.writeLine with the parentheses, just like before. And this time, say that we want to display, if we want to display y, you just type it in here just like before with the x, except for this time, we want it to display, let's say we want to add them together. Inside of here, all you got to do is x plus y. So then what it'll do is it'll add the values together, and then it will print it to the screen after it adds them together. And then if you hit run, you'll see it prints 5, which is this right here. It'll print x to the screen, and then we create the 1.5, and then we add 5 and 1.5 together, which will then print 6.5. There is one more thing I wanted to bring up here quick. So I pointed out the curly brackets before. just some terminology here. So the curly brackets, that's called a scope. So anything inside of those curly brackets is a scope, which is like just a chunk of the code that's all like grouped together basically. So in this program, we have two scopes. We have this big one here, and then we have the smaller one, which is where main is. Inside of each scope, you can only have the variable, like if you make multiple variables, they have to have unique names, just the computer knows what you're talking about. So if I wanted to create another variable, I couldn't make another variable named x, for example, because if you hover over it, it says a local variable or function named x is already defined in this scope. And that's just so the computer knows what variable we are talking about when we want to use x, so there's not two of them. Otherwise, it's going to get confused. If you want to, say I want to set x to something else, instead of writing int x, you just write x equals 8 or something. So in this case, we're not creating a new variable, we're just setting it to a new value. And if you were to run this code again, you'll see that change reflected in the output. So it'll print out 8.8 plus 1.5, which is 9.5. And if you notice, you can also combine the plus sign. You can combine that with different types. So if we want to print the hello string up here, this is just an example, but if you wanted to print that with a number at the end of it, like x, all you have to do is do that, and then it will add them together. And it should print Hello Game Development Club 8. So yeah, cool. One more thing I wanted to talk about was comments. So a big part of programming is, I mean, right now it's okay. There's not really much to it. But once you get to writing bigger applications or like a game or something, it's kind of easy to get lost in all the code that you're writing. So the easiest way to kind of keep track of what's going on is to write comments in the code to kind of like explain what you're doing. There's two different types. You have, the first thing you have is just a normal comment. So you write 2 slashes and you'll see it turns green, and that means it's a comment. In this case, you can just write whatever you want, so I can explain like this is a phrase or something. And this, when the code is running, all the comments get completely ignored, so this is just to help you understand what's going on. And say that you have a lot to write, not just enough that'll fit on here. If you have a lot of stuff you want to write, you can do a multi-line comment. So this is a singular line. This is just on line 9. Whereas if you want to write a lot of stuff, you do a slash and then you do a star. And then on another line, you do a star and then a slash. So then now anything you type in here will all be a comment. So you can type in a lot of stuff. In this case, I just kind of mashed my keyboard. But then this way, if you want to kind of help write some notes, try to remember what's going on, then you can write some comments. It might help. I'm just going to delete this over here. Okay. All right, so we've played around a little bit with variables and printing stuff to the screen. So what if we want to be able to get input from the user? If you want to like ask them for their name or their age or something, or if you're creating a game, in which case, not right now, but maybe you would ask them for the W input or something. How do you do that? There's a lot of different ways. With the console, it's basically just going to be input and output. You know, I ask for a name or something, and I'll get it back, or a number. And the code provides a way to do that. It's really similar to console.writeLine. So what we're going to do is down here, I'm going to create a new variable, a new string called name. And if I don't want to set it to anything yet, you just put a semicolon right after name instead of equals, and then this will just leave it to blank or empty. And then if I want to ask the user for their name or something, I would do name equals console dot read line. So what this does is down here, I'll show it in a second actually. Down here it'll stop and it'll wait for the user to enter something. So the code just sits here and does nothing. And then as soon as the user enters something and presses the enter key, then it will take whatever they entered, put it inside of this variable name, and then you can do stuff with it. So for now, I'm just going to write another console.writeLine. And I'm just going to put name inside of there. So what this is going to do is it's going to print the stuff that we have from up here, and then it's just going to sit here and wait for us to enter something. And then once we enter something, it's just going to print it again. So I printed the other stuff we had before, so now I'm going to write Mitch, and you'll see that there are two of them. The first one is what I typed in, and then the second one is it printing it back out after it got the data that I typed in. So now that we have that, now we have like a way to get input, and this is how you can make more complex programs. Maybe make like a mini game or something, or like a hangman game. You'd be able to do something like this. So say that you want to get a number. It's actually a little different if you want to get a number. It's going to be similar though. I'm going to delete, or I'm just going to comment this. If you want to comment a bunch of stuff at once, if you just highlight it all and then hit Control/, Replit will put comments before all the lines. It's really nice. But I'm just going to comment that out just so it's ignored and that it doesn't ask us for our name every time. Actually, I'm going to do that with this stuff too. Ooh. Okay. So what if you want to get a number? Let's do a console.writeLine, and I'm going to put a direct string in here, so I'm not going to put it in a variable. I'm just going to type it in. So you do double quotes, and then I'm going to put in like enter your age, and then a semicolon at the end of the line. So this will print enter your age to the screen, and then we want a way to get that age. So first I'm going to create a string variable called age, and I'm just going to do equals console.readLine. So if you notice, I basically just combined these two lines together up here. So you can separate it like this. You can make the variable, and then on another line you can do the equals sign. Or in this case, I just did it all at once. Either works. And this will work okay. So if I want to do like console.writeLine, and I want to say like, oh nice, your so if I want to like have it say something in the middle, say like, oh nice, you're 10 years old or whatever, how you do this is similar to kind of what I did before with the plus signs. So you type whatever you want inside of the double quotes, then you do a plus, the name of the variable, in this case it's age, and then plus, and then you do another set of double quotes, years old. So now what it's going to do is it'll print to the screen, enter your age, we will type something in, and then it will print, oh, you're nice, you're this age. And just for an example, we'll run it quick. And we'll just put in like 6 or something. And then it'll say, oh nice, you're 6 years old. So there is one problem with this. It does work the way it is, but the type is a string. So all the computer knows is that this is a word. It's not actually a number. So we want a way to turn it into a number so that we can use it with other things. Maybe we want to do some math to it. It's, you know, like how would you do math with a word? You got to turn it into a number so that you know, so it knows how to do multiplication and stuff like that. So I'm going to create a float called num, short for number, and we're going to do equals float.parse, and I'll explain what this is doing in a second. And then you put age inside of there. So this is similar to console.writeLine. It's calling a function, and so inside of for an input to the function, instead of like console.writeLine, the input is a string or a variable, and it'll take that input and it'll put it out on the screen. Well, in this case, it's taking the input, which is this age string, and then C# does some fancy calculations in the background, and it'll turn this string into a number, which will then be put inside of num. So if I want to, I'm gonna cut and paste this onto the next line. And so now, if I replace in the console.writeLine here, when it says, oh nice, you're blank years old, I'm going to replace it with num instead of age. And it will work exactly the same. The only difference is that if I enter something goofy, if I like enter the word no, the program will crash. And this is just because this is not a number, and so when it's doing the parse, when it's trying to turn that word into a number, it's finding the letters and it doesn't know what to do, so the program just ends. Whereas if you run it and you enter a real number, if I enter like even something like 5.2, then it'll know it's a number, nothing, it'll run and it'll go, it'll finish the program. Yeah, now that it's a number, if I want to do some math to it or something, then you could do like num equals num times 2. So this is just an example, but what this is doing is that it's multiplying num times 2. Hopefully this makes sense. So you're taking the value, so whatever they enter is their age, and you're turning that into a number. Then once it's a number, then you can do math to it. So you can multiply by 2, and then it'll take that value and set it back to num. Yeah. So this might make sense if we run it. So whatever we enter, it's just going to double. So if I say I'm, my real age, if I say I'm 20, it's going to think I'm 40, just because it takes that number and it's multiplying it. All right, but one thing that is wrong with this so far is, say I enter a negative value. It still works, but I can't actually be a negative amount of years old. That doesn't make sense. So how do we like create a way for it to like know? How do we create a way for it to change, to adjust to wrong values or something like that? And this is where conditions come in, or conditionals. So normally in math, right, these are going to be familiar. You got like the less than sign, you got the less than equal to sign, greater than sign, greater than equal to sign, equal sign, and somewhat uncommonly the not equal sign. And these are all things that you can use in code as well. Typically how you use it is inside of something called an if statement. So I'm going to draw first. So inside an if statement, you write the word if, and then it'd be like a set of parentheses. Inside of here, if you write a conditional, if you tell the computer something, like, how do I explain it? Yeah, I'll just write some code first, and then we'll go from there. So say that we want to check if the number the user entered is negative, because a negative number, negative age doesn't make any sense. We would create an if statement like this. So this will use its own set of curly brackets. And what's going to go on here, inside the parentheses, so if num is less than 0. So what's this going to do is the user enters a number, and then it'll check, okay, if the value inside here, if the number the user entered is less than 0, we're going to run this code inside of these brackets. If the number is greater than 0, it doesn't matter. It's going to skip these brackets and just keep going. So say that the number is less than 0. We'll do a console.writeLine and say, like, that's not your real age. So if you were to run this, if you enter a positive number or a negative number, you'll get a different result. So if we enter like -4, it's going to say that's not your real age. And now if we enter a positive number, like 16, you'll see it won't print that because num is 16, which is greater than 0, or greater than or equal to 0. So, but say that we want to, if you notice when we did the negative number, it printed both of these. I'm going to run it again just so it's up. So it prints both of these. Well, say that we don't want it to print this when the person enters a bad age. The way we do that is by adding to this if statement here, and what is called an else statement. So after that bracket, if you write else, and then another set of curly brackets, this is like what happens when this is not true. So if the number the user enters is negative, if it's less than 0, it'll run this code. Else, so if the number is greater than or equal to 0, then it will run this code down here. So I'm going to paste that back in. And then now if we run it, if I enter a negative number, it'll say that's not your real age. And then if I enter a positive number, it'll say, oh nice, you're 60 years old. So, and it doesn't print the other one. There is one thing I forgot to write down in my notes, which I want to cover really quick, and that's loops. So say that you want to run something a bunch of times in a row, like 100 times or an infinite amount of times. This is when loops come in. So this is when you're going to repeat something over and over. Say that you're making a game. Typically games have a game loop. which is just something that keeps running over and over until it's over. Or say that you want to do something like 100 times, you'll use a loop to do that. And so C# has two different types of loops. I'm going to do the easier one first, and then the second one will make more sense. And this is called a while loop. I'm going to comment all this first, just because we don't need it. You highlight it all and then do Control/, and it'll comment everything automatically for you. So for a loop, say that we want to do something 100 times. The easiest way to keep track of how many times we've done something is to create a variable, like a number, to keep track of, okay, we've done it, the loop one time, we've done it 2 times. And so in this case, I'm going to use an int, which is a whole number. And the reason for that is just because, like, an int is we're not going to run the loop half a time. So it doesn't make sense to use a float because we don't need it to be a decimal number. So I'm going to do int I, and I'm just going to set it equal to 0 for now. And this is how we're going to keep track of how many iterations of the loop we've done. So what we're going to use is called a while loop. It's similar to an if statement, except for instead of if, you write while. And then inside of here, you have another condition. So it's going to be just like this here. Num is less than 0. In this case, we're going to do if I is less than 100. So if we want the loop to run 100 times, then by checking if I is less than 100, it'll keep checking every time. But the problem right now is that we're never changing I. So this loop is just going to keep going for all of eternity unless we change I as well. So inside of it, we're going to do I++. And so what this does is it will just add 1 to I. Whatever I is, it'll add 1. It's basically the equivalent of I equals I plus 1. Similar to what I did before. I might have deleted it. But if you want to add to itself, you can do I equals I plus 1, or the easier way to write it is just I plus plus. So now, every time this loop runs, it'll add 1 to I, and then it reaches the end of these curly brackets, so it goes back up to the top, and it checks, okay, if I is less than 100, we keep going. And so it'll keep doing this. I will be 1, 2, 3, 4, it'll keep adding 1 to it, until it finally reaches 100. I will be equal to 100, it'll check 100 is less than 100, it is not, so then it stops the loop, and it keeps going on in the code. And so just so you can see this, I'm going to do a console.write line I inside of the loop. Or here, I'm going to put it before the I++. Okay. So if I put the console.write line, then it'll print the value of I to the screen every time the loop runs, just so we can kind of visualize it and see what it's doing. So if you give it a second, then you'll see it prints out 100 numbers. It goes from 0 all the way to 99. And this is the loop running. So it starts with I equals 0, it'll print that to the screen, and then it'll add 1. And then it restarts the loop. So I is I is still less than 100, so then it prints it again, which is it's now 1, and then it adds 1. Keeps doing that over and over and over until it prints 99, then it adds 1, now it's 100, but now I is not less than 100, so it stops running, and then it only does it 100 times. And so that's a while loop. there are different things you can do with it, but there's also another type of loop which is used, and this is the reason why I use this example. It'll hopefully make more sense. And this is called a for loop. So a for loop takes the while loop that we just wrote and uses that specific format of like going from 0 to 100 or something, and it makes it like easier to read, this just per se. So we'll do for, and then we'll have some parentheses here and some curly brackets. And then inside the parentheses, it's a little different than a while loop. This is going to have more information, and it actually uses all, like it has everything in here except for the console.write line. It'll have that all compact inside of here. So we'll do for, and then int, I'm going to use k since we've already used I. Set that equal to 0. And then you do a semicolon. And then you'll do k is less than 100. And I'll come back and explain this. And then k plus plus. Okay. So this is going to do, or here, let's write console.write line. There we go. So this is going to do exactly the same thing as the code up here. And what the for loop does inside of here has 3 different parts. The first part before this first semicolon is the initialization. So it runs at the very beginning of the loop. In this case, we're just setting, and we're making a variable called k that we can use inside the loop. And then it's checking, and then the second part is what it checks inside the loop. So this is basically what's in the middle here is the same as this while loop, what's inside the while loop. In which case, we're checking, making sure k is less than 100, because we want it to run 100 times. And then the last part after the second semicolon inside the for loop, we have the part that runs, this runs at the end of every loop. So in this case, instead of having I++ at the bottom here of the while loop, we actually put it inside the for loop parentheses. So yeah, if I comment this out and run it, you'll see it does the exact same thing. There are advantages and disadvantages of each type of loop. The main point in time when you use a for loop is when you have a situation like this where we're trying to do something like X number of times, where you know the amount of times you want to do it. So if you know you want to do something 100 times, or you know you want to do something like 10 times, you'd use a for loop just because it's nice and organized. You know, you can see everything all in one line. Whereas with the while loop, if you have a lot of stuff going on, it might be easy to lose lines of code, get lost trying to read it, and you might run into other problems down the road. But a while loop is also a little nicer for other things that you don't know how long it's going to last. Like if you are making a game, you would use like a while loop, for example, because you don't know how long the person is going to run the game. It could end, they could play for 5 minutes, they could play it for 5 hours. So, yes.
For the k++, if you wanted to increment more than just 1, would you just write like k plus 2, or is that not?
If you wanted to add more.
Yeah.
Yeah. So, you have.
Is there like a shortcut?
Yeah. There's a. I'm gonna write them all out really quick. So say that you have a variable x. There's a bunch of different ways to add to things, and they all do roughly the same thing, but I'll write them all out here. So the most straightforward way to do it, if you want to add 1 to something, would be, or like add a number to something, if you want to do 2, you do x equals x plus 2. And you could put this inside of here, but it would look a little tacky. The shorter way to write it is do x plus equals 2. So the plus equals basically just shortens this because it knows that you're going to add to x. So the plus equals is shorthand for this line here. They both do the same thing, but in this case it's just a little shorter. So you're adding whatever x is equal to, you're just adding 2 to that. The x plus plus only works with 1. It only adds 1, only ever. So if you want to do anything other than 1, if you want to do 2 or 3 or 4 or whatever, you would use plus equals and then that number. So yeah, if you want to do it inside the loop, you do plus equals 2, like that. And then now if I were to run the loop, it would print all the even numbers to 100, basically. So 0, 2, 4, 6, 8, 10, blah, blah, blah. And then all of these things here, they can also be done with other operators, which I guess I should have written those out for you. So if you want to add things together, it's the plus sign, and it's pretty straightforward. Same with the minus sign. Subtract is the minus sign. If you want to multiply, that's going to be the asterisk. And then divide is the slash. I'm trying to think if there's another operator I'm not thinking of.
Modulus?
Yeah. Yeah, so if you want to do the modulus, that's the percent sign. What the modulus is, if you don't know, it's basically, like, you know, when you're in like 3rd grade and they're teaching you how to do division, usually you start with pretty basic. You do like, 7 divided by 3 is 2, remainder 1. Well, that's basically, the modulus is the remainder. That's all it is. So if you were to take, like I said, the 7 modulus 3, that would then give you the value of 1. 7 divided by 3 would be 2, remainder 1. And so the modulus just gives you that remainder. This is nice in certain situations. If you're, typically when you work with like lists or something, it might make more sense. But that's not something I probably won't cover today, but just so you know about it. And then those can all be used with stuff like this, other than the plus plus. So you can do x minus minus as well, but you cannot do like x times times. That does not work. But you can do like x multiplies equals 2. So this will like multiply x by 2, stuff like that. Or you can do x divide equals 2. If you want to divide x by 2. Yeah. So I got 2 more things I want to try to cover. Next part is functions. So functions are kind of like math functions. With the, like the one with the curly f like that, right? Or wait, it would be something like this. So you have like x equals f of y. If you ever take algebra, you'll see something like this. So y is the input to the function, and then x would be like the output. And then f is the name of the function itself. So in code, we have the ability to create our own functions, and this lets us kind of break things up so that if we want to repeat something, maybe not in a loop, say we want to do something twice. A good example is like if we want to ask the user for a number. Instead of writing that code over and over and over again, you can just put it inside of a function so that you can use it multiple times and keep doing that. This might make more sense if it's the right one. So, oops, I'm going to zoom out a little bit. So main itself is a function. And we're going to follow something, the format is kind of something like this, where you have, in this case, string args. This is an array, which is basically just like a list of strings, of words and stuff. This is the input to the main function, which we're not using it. There are certain situations when you use it, but in most cases you probably won't. But we're going to create our own function that we can use that is kind of similar to something like this. So if we want to create our own, this first curly bracket here is the end of main. So if you want to make your own function, it has to be outside of other functions. So, but it still has to be before this, which is the end of the program class. So in between these two curly brackets is where we're going to create our own function. And it'll follow something like this. Some of these words I'm just going to type and then I'll explain them after I type them out. So we're going to do public static void. We'll just call it like print for now, and we'll add to it. Okay, so public. I'm not going to get too deep into exactly what this means. If you write a bunch of code, there's these things called access modifiers. That's what public is. It's basically just saying that if you have other code somewhere else in a different file or something, public allows you to use that code in a different file or in a different class, for example. Or you can make it private, which would hide it from other code outside of this class, outside of this file. So in this case, it doesn't matter because we only have one file that we're working in here. Static, I'm just going to completely ignore for now. Just know that it's there. Just because main has static. Static is basically just means that there's only one of it ever. So there's only like inside of this class program, there's only one main. It's static, so there's only one like instance of it. And because main is static, this also needs to be static so they can talk to each other. And then void. So void is more important. Void is the return type. So inside of here we have x. So x is like the output value from f of y, right? So if this is like an int x equals blah 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 f of y, that return type is an int. But in this case, the reason why I wrote the word void actually means that we're not returning anything. So in this case, we're just running a function and we're not expecting it to give us anything back. It's just not going to give us anything back. And then inside of the parentheses here, there's actually just nothing. And that's because we also have no input to the function. So in this case, if there's no output and there's no input, that means that anytime we use it, it's just going to do the same thing, which is what we want for now. So I'm going to write a console.write line in here, just so we know it's working. And I'm going to write like hello GDC. So now if we want to use this, as of right now, nothing's going to happen. If I were to hit run, it's just going to do absolutely nothing. We got to actually call the function. So we got to tell it that we want to run the code inside of the function. And how you do that is inside of main, inside of this function, there's a lot of stuff there. You can write print, parentheses, and then semicolon inside of the curly brackets of main. So then when main is ran by the computer, then it hits this line of code and it's like, okay, we want to run the code inside of print. So then it hops down here, it'll run all this code within these curly brackets, and then it'll go back to print up here. So now if I hit run, it should print hello GDC to the screen. And like I said before, if I want to reuse it, if I want to do it like multiple times, if I type it a few times and then hit run again, now it'll do it 3 times. It'll keep going back to that code inside of print and then going back to main. And then because we told it to do it 3 separate times, it'll run back and use that function 3 separate times. So this is just like a pretty bare bones example of something you can do with a function. say that we want it to do something more complicated, we can combine some of the code that we've written up here and do something like that. But what I'm going to do for an example is have, let's do a function that will add two variables together. And this will help show you like how to return values, how to send it back, so that we can use data as well as like have different inputs and stuff. So I'm going to create another function. And we'll do public static again. And then instead of void, we actually want to get something back out of this function. So I'm going to do float because it's going to be a number. And then we'll just call the function add with parentheses. So inside of here, this is where we're going to list out all the different things that all the different inputs that we want. So in this case, if we're going to add two numbers together, then we'll have to write those out so it knows what inputs we want. So if we both want numbers, we'll use a float, and then we'll do like x, comma, float y. And so this says like, okay, here's the function add, and we have two different inputs to it, x and y, and they're both numbers, so that we can use them. So inside of here, if we want to actually like do something, for example, if we want to actually add them together, I'm going to create a new variable called z, and I'm just going to set that equal to x plus y. So we'll add them together, and then the value of them added together is now inside of z. And then we'll type the word return z. So what this is going to do is whenever we call the function, which I'll show here in a second, it'll take in these two inputs, it'll then add them together, put them inside of this variable, and then it will return them, so it'll send it back. So here's an example of like actually using that. So we do like int1 equals 1, or sorry, float. Do float1 equals 1. Float2 equals 4 or something. That might get confusing, which how I just named those, but whatever. These are our two inputs that we want to use. And so if we want to get it back, if we want to use the function, we can do float result. So to say this is the result from the function. We can do add equals add, and then we will give it the two variables, the two inputs. And so this is kind of working similar to the console.read line that we did before, so this is also a function. Readline is also, or console.readline is also a function. It has no inputs though, but it does have a return value. It has an output, which is what the user inputs to the screen. So in this case, add has two inputs, and so we're telling it, okay, 1 is now float x, and 2 is now float y. And then it'll take those in this function, it'll do whatever we tell it to do, and then once it's done, it returns that value, so it sends it all the way back to this equal sign, and we'll set it inside of result. So now if you want to make sure it's working, you can do console.writeLine result. Oops. And if you hit run, I guess it disconnected from the internet. Hit run again. Yeah, the one downfall of using Replit is it's a little slow sometimes, just because it's online. If you actually download it, use an application, it's way better and faster. Okay, but if you'll see here, we have the variables 1 and 2. So 1 is equal to the number 1, and 2 is equal to the number 4, which might be confusing, but yeah. So you pass those in. X is now equal to 1. 2 or y, is now equal to 4. So we take 1 plus 4 inside of here, and then we send it back. So then result is now equal to 5, and then now we're printing that to the screen, which is what we get here. So that's just a nice way to kind of display how you use functions, how you create different things that do stuff like that. Everything we're using here can all be combined. You know, you can make loops with functions, you can run functions inside of them, you can make a function with a loop inside of it. It just takes a lot of experimentation to do stuff like that. So there's one more thing I wanted to cover before we're done here, which is classes. So classes are a little more complicated to understand. The only reason why I'm covering them though is because like if you try to create games and stuff, you're going to probably use classes because it's like objects and stuff. And I'm going to try to draw that out and explain it here. So a class is basically a blueprint. If you look back in the code, we have class program. So everything inside of here is happening inside of a class. But what is a class? Say that we have a person. So we have a little guy here, right? I'm a great artist. Okay, so we have a person, and we want a way to create an object or something that will represent this person inside the code. And how we're going to do that is we create a class. So the class will store a bunch of things inside of it. That's a curly bracket, by the way. That will hold data and do different things for this person. So what are some things about the person that we might want to know about? Well, let's see. We might want to know his name, their name, or their like favorite number, or something else. But in addition to like numbers and like data that we know about them, we also might want to know some, or like have some things that they can do. So say that, you know, what can this person do? Well, they can also like run or sleep. And I'll explain why I'm putting those there in a bit. And so they also have different things they can do. So classes consist of variables and functions, similar to what we've been doing before. As you can see, so class program, so this is like the whole code that we're writing. It has a function, main, so main defines how it runs, how it works, but then we also have these different things, which these might not make as much sense for the diagram that I'm trying to draw here. But if we make a person, they're going to have different stuff like this. So let's write this into code just so you know what it looks like. So since we're making our own class, it's actually going to be at the bottom of the file after the last curly bracket. And we'll do class person. Then you'll do the curly brackets. It can be however you want. So if we want them to have different data, we can create different variables, and it's similar to what we did up here, right, where you do float something. So if it's their name, let's do public string name, and we won't assign it to anything quite yet, but you'll have like public string name. So public means that we can use it anywhere. String is, you know, a phrase or words, and since it's a name, it makes the most sense to have it be a string because it's going to be like a bunch of letters. And then if we want to do their age, we would do public float age. And so this will hold data inside of here. Yeah, hopefully this is making sense so far. Classes are kind of a hard thing to wrap your head around, especially at first, but I just want to like introduce them at the very least, just so that once we get around to using stuff with Unity, it'll hopefully not be as confusing. And then we could create something similar to this as well. Like if we want to have a function, we would do just like what we did before. We do not static though. You do public void run, and then we can write something like console.writeLine, and we could have it do something in here. What's nice about making your own classes and stuff though is that because there are variables inside of this class, we can actually use these inside of the functions to help do different things. So in this case, like up here, we just have, in this print function, we just have it saying like, oh, hello GDC. Well, in this case with the person, maybe we want the function to change based on the actual person that we have. So we can write like, something is running. However, we also have the name variable. So if we do name plus is running, what this is going to do is once we create a person, it will have their name, and then it will, when we call run, it'll print that. Print name is running. So whatever the name is, it'll print that. Let's actually do that up here just so you can actually see it working. Hopefully this will make more sense. So I'm going to remove all this. We're going to comment it out. Oops. So now that we have a class, so we have this blueprint, and this doesn't actually have any like data in it, right? You know, if you have an actual blueprint and you want to build a house, we haven't actually built the house yet. This is just the diagram of like what we want it to look like. So if you want to actually build the house, like per se, if you want to create a person, it would be similar to variables like we did up here. So where like here we have float, float 1 equals 1. We're creating a new number and we're assigning it to 1. Well, in this case, we want to create a new person, so it's going to follow that same format. We do person and call him Mitch equals, and this is where it gets a little different, new person. And it kind of looks like a function if you look at it, but there's one difference, which is this blue new word here. And because this is a class or a struct, because it's an object and not just a number or something really basic, we have to use the new word. And what this is basically just saying is we want to create a new one of it. And there's like a lot of technical reasons as to why you don't have to do that with numbers. But the main reason is because a number is what's called a primitive type, which is like already built into the computer, like the actual hardware. Whereas with a person, like we are creating that in the code. And so, this computer didn't come built in with a person class built in. So because we're creating our own, we create a new form of it. So now we have this person. And even though I named the variable Mitch, this name variable inside of the person, this thing, doesn't actually have a value in it yet. So if I want to assign one, I would do Mitch dot name equals, and then like Mitch or something. So what this is doing here is it's saying, okay, this person Mitch, this variable, the dot says that we want to access something inside of it. And so then it goes down here, and we can use any of this stuff by using a dot and then the name of it. So if you want to use this variable name, we do dot name. And so now it just acts like any normal variable. Like if I were to have like a string name, I would do string name equals Mitch. But in this case, like the string is inside of the person. So if we want to use it, we do it Mitch dot name. And then we can set that equal to whatever we want. And so now, say that I want to use this function, it's going to be really similar. Why is the spacing so off? Okay, we'll do Mitch.run. And so this is really similar, except for instead of using a variable now we have a function. And if you'll notice, it's kind of similar to like console.writeLine. So console is actually a class that we have been using this whole time. But in this case, we have our own class and our own function that we made called run. And so it's similar to calling what we did here, except for this time, it's inside of this object. So we have to use the dot and then run. So now if you run the code, and you'll see it prints out the phrase, Mitch is running. So what this is doing is it's creating the person object, and you're assigning its name, or assigning a variable, and then when it calls this function, you do mitch.run, it runs all, or the code pops down here, it'll run this line of code, and because we set the name to Mitch, it'll then replace that in here as the variable, print that to the screen, and then it'll use that stored data. So now, what's nice about this though is that if we want to create multiple people, we can write this code again, but we can do like person Hayden equals new person. Hayden.name. This would all be pretty similar. I'll explain it here in a second. So now you'll see it prints Mitch is running, and then it prints Hayden is running. So we have two separate people. We have me, and then we have Hayden. And they each have their own name, their own age, and their own run. And so they all act a little differently based on the data that is inside that person. So this is just like really bare bones. Typically in games, it might make more sense when you use objects, because if you have like like Mario, for example, they probably have a class for Mario, they have a class for a coin, a pipe, all the different types of objects, they'll each have their own class or whatever, most likely. And that's just how you kind of like organize things, and it helps, classes just help like be able to relate the real world into code, help visualize it a lot better. I've covered everything that I wanted to cover for today. I can post all this code in the Discord. I'll probably clean it up and comment it so it is a little more helpful. But from now until about 9 or whenever, if you want to stay here and get help with anything, that's fine. Or even if you're working on any normal projects, I can help with that too. But yeah, that's the end of the workshop. If you have any questions or anything, let me know. Yeah. Also, one announcement before everyone leaves. I posted this in the Discord, but we do have office hours now. So every Tuesday and Thursday from 5:30 to 7 in room 2253 in the Student Innovation Center, we have office hours. And basically what this is, just either like me or Hayden or somebody, we just kind of hang out there. If you want to come and get help on literally anything from like a homework assignment to an actual video game or something, that's like the time to do it. We're both pretty knowledgeable in this stuff, so we'd love to help people out if you want help. So, yeah. Without further ado, go forth, make games, and be awesome. Thanks for coming.